Now, use Chase's. Okay, so if you look at the formula sheet, the top left, my left, top right for you, the A over sine A equals B over sine B equals C over sine C, that's sine law. Write sine law beside it. Sine law on your formula sheet. Okay? The two bottom ones are cosine laws. Now, if you look at the bottom left, you have a squared equals b squared plus c squared, da 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 da. That little a always represents a side, right? So right beside this, we're finding a side. That's when you have side angle side, so SAS. So beside the a squared one, the one on the bottom left is when you have SAS, side angle side. So it's a squared equals b squared plus c squared minus 2bc cos a. You use when you have side angle side. The third one, cos A, where you're looking for an angle, is when you have side, side, side. So when all you have on the triangle is all three sides, you're going to use this cos formula, cos A, because you're finding an angle, okay? So this one here is when you have side angle sides, when you have some SAS, SAS, and then this one's when you have side, side, side. All right? The side angle side, 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 side. Both of those formulas are just one of the formulas rearranged, actually. So if you look at the one on the left, the a squared equals b squared one, that one literally is just the rearranged formula of the one on the right. The two cosine law formulas are actually the same formula. They're just rearranged to solve for different things. Okay, so there really only is one cosine law. We just rearrange it to get two different kinds. All right. So to use the cosine law, you must have all sides. You must have all sides, and you're looking for the angle. So side, side, side. Or you have to have side, angle, side. Side, angle, side means you have the side, the angle in between, and the other side. So side, angle, side. You can't just have two sides in a random angle. That does not mean the same thing. When you have side, angle, side, it means you literally have the side, the angle in between, and the other side. So when you have SAS, side, angle, side, you're going to use cosine law. Whenever you have a side angle pair, you use sine law, remember? So there's a very difference. You have to be able to look at the triangle and figure out what you need to find. And I always say to you, if you know two angles, find the third. If you have all three angles, you can use sine law no matter what. Okay? If you have all three angles, you're using sine law. So let's go through and figure out what we need to do here. So to figure out what we have, the first thing I always do is label. So we have angle B, this is side B. We have angle A, this is side A. We have angle C, this is side C. Okay? Do we have a side angle pair? That's the first thing we ask. Do we have a side angle pair? We have angle A, we don't have side A. We have side C, we don't have angle C. We have side B, we don't have angle B. And we can't find these angles because we only have one. Remember, if we have two angles, we always find the third? We can't. But we do have side, the angle in between, and side. So we have SAS. If we have SAS, we're going to use that formula on the formula sheet that you use for SAS. A squared equals B squared plus C squared minus 2BC cos A. Now, you're not always going to be asked for side A, so you have to be able to rearrange that formula. This is always the side you're looking for. And whenever you have SAS, whenever you have side, angle, side, even if you're asked to find a different angle, you have to first find the third side. There's no choice. If you have side, angle, side, you have to find the third side immediately. Even if they ask you to find an angle, that's fine. You're going to have to do sine law after that and find the angle. But if you have side, angle, side, you have to find the third side, even if that's not what's asking for. You have to find the third side, and then you can find an angle using sine law. Okay? You have to find the third side. So the side we're missing, luckily, this time is A. So if we're missing A squared, it goes here. This A also matches the angle. So this also has to be cos A. And then these letters are just the other two sides that you know. So that's how you rearrange this formula. So say you didn't know side P instead. You'd have P squared here and a capital P here and the other two letters here. That's all the formula is. It's just changing it, right? I'm not going to give you the formula for every single letter makeup of a triangle that's possible. You have to know how to change that. It's not hard. So let's fill in what we do know. We know a squared stays a squared. We know little b is 6. We know little c is 3. What if I wrote 3 squared and 6 squared this way? What if I went 3 squared plus 6 squared instead of 6 squared plus 3 squared? Does that change anything? No. So if you wrote c squared plus b squared instead of b squared, it doesn't matter. All that matters is that these letters are these two sides you know, okay? Minus 2 times 6 times 3 cos the angle in between. Cos 36. Now it's in degrees, so you have to make sure your calculator is always in degree mode, right? When it resets in radian mode. You guys need to take advantage of the fact that it's always in degree mode, because next year that is not the case. So you need to be like, just take it in and be so excited that all you have to have is degree mode, okay? Because next year we are going to flip back and forth between radians and degrees. So take full advantage and happiness in the fact that yours is only in degree mode. You need to enjoy that, because next year you're not going to get to enjoy that. So enjoy it. Take it in. Be happy. Make sure it's in degree mode. Don't be that person who goes, Mrs. Lepp, I did the whole thing in radian mode. Because I'll be like, dude, you're supposed to appreciate the degree mode, okay? Be one with it. So this entire year, even on your final, on your midterm, you have to have your calculator in degree mode. Never will you want it in radian mode, okay? Now, I want to know A. I want to know A by itself, okay? It's squared right now. So I have to remember to square root this whole thing. What's the greatest thing about this cosine law? The greatest thing about this cosine law that never happens ever is you can put this entire thing all in your calculator at once. That never happens. That is not the case ever. For this cosine law, though, it's awesome. You can put the entire thing in, and you don't have to worry about brackets. The other cosine law, you have to worry about brackets, but this one you don't. So try it out. Everyone has to try it in their calculator, because what's the worst case scenario? You know how to do this question. You just type in your calculator wrong every single time. That would be horrible. So we don't want to be those people. The other thing about calculators, which I'm sure has been told to you before, these calculators are only as good as the operator, so you need to put them in the way that it says. So how do you say this? You say 6 squared plus 3 squared. Do you say negative 2 times 6 times, or do you say 6 squared plus 3 squared minus 2 times 6 times 3? Do you say negative 2 or minus 2? You say minus 2. If you say minus 2, you have to press minus 2, not negative 2, okay? These calculators do not work properly if you don't use them correctly, because if you put minus 2 in here, it's going to start multiplying. It's not going to actually subtract. It's going to take this plus this multiplied by negative 2 times 6 times 3. That's not what you want. You want minus 2 times 6 times 3 cos of 36. And to the nearest tenth, what do you get? 4.0. 4.0. Now, 3.9843, but it rounds to 4.0, right? Okay. Now, I rounded this. I've told you before, do not round until the very last step. I've said that to you. You cannot round until the very last step. You are going to have numeric response, and if you round before the very last step and you get 4.1 and the answer is 4.2, there's no little happy old lady who's like, oh, sweetheart, I'm sure you meant to have 4.1, and they fix it on your diploma and still give it to you. No, they don't love you. It's a computer. They have no heart. There's no love, okay? So you don't want to round till the very last step because you don't want to have it rounded wrong. But why can I round here? This is the very last step. It says determine the length of side BC. What is side BC? Side A. I'm done. Got it. Good to go. Now, why do people get this question wrong if I ask for an angle? Because if I ask for angle C instead, you guys just really want to find what it asks for. So if it says, I want to find angle C, you guys are like, okay, what formula can I get that I can immediately find angle C? There is no such thing, okay? If you have side, angle, side, you have to find the third side first, and then you could find angle C if I asked you for it. But there's no formula when you have side, angle, side that will directly get you an angle. Okay? Keep that in mind. Side, angle, side, you have to find the third side with that formula. Okay, flip over. Don't see a word problem and immediately stop doing the question because you want to cry inside. Okay, we're going to work through word problems. You guys can do these. You can do word problems, I promise. And to be honest, 30-1 has quite a few word problems. 30-2, 80% of the test is word problems. So you're not going to get around it. So if you're like, I'll just go to -2 and not do work, not going to happen. 3 of the units in -2 are all words. So you guys have to be able to get over the fact that word problems are hard. And why do I say that? Because I had to. When I was in high school, I was like, oh man, a word problem, please no. Please no. And I loved math. And I was just like, no, just tell me what the things are, draw it for me, and I will just do the math. Just let me math, and I will be happy. Truthfully, word problems are not hard. It's just wrapping your head around the fact that they're not hard and trying the question. So let's do it. A surveyor needs to find the length of a swampy area near Fishing Lake, Manitoba. The surveyor sets up her transit at point A. So transit is that little thing that they stand behind and they can like move and they can look at. You've seen them before, surveyors have them, right? It's a transit. She measures the distance to one end of the swamp as, so let's draw a swamp. I'm not the best artistic person. This is my swamp. Isn't it pretty? It's a pretty swamp. It's got a little guy in it. That's the little guy in the swamp. Don't be jealous of him. That's a swamp monster. He's a happy guy. Okay. She measures the distance to one end of the swamp as 46.82 meters. If I say it's to this one instead of this one, does it matter if it's not right? Just pick a side, believe in it, and go for it. Okay. So here, we got 468.2 meters. The distance to the opposite end of the swamp is 692, and it looks like it's a little bit more, so that's why I saved it for that one, but it'll be fine. So to the other end, it's 692.6 meters. Now, the angle of sight between the two is 78.6 degrees. Which angle is that? A, right? It's the sight between. Not a hard question. You just have to go for it and not sit there for 10 minutes crying and thinking, oh gosh, it's a word problem. You can do it. I know you can. Okay? Determine the length of the swampy area to the nearest tenth. So they want this piece. Oh, I just see he's now standing on the length of, that's Ogopogo. He's there. So we're asking to find the third side. Now, these ones aren't labeled any letters. Should I just like fall to the floor and cry a little, or should I just give them some letters? I'm going to label it Q, because Q doesn't get enough love. And D, because I just thought of D. Okay, and I got A. So I'm going to label them. This is angle A, this is side A. This is angle D, this is side D. Angle Q, side Q. So I have SAS, I have side angle side. The moment I have side angle side, I just write the side angle side formula because I have to use it and I have to find the third side, even if it is not the one I'm looking for. Luckily, it is. So A is the one I'm looking for, so I leave it as A. And my angle is going to be A as well, because these two match. However, B no longer is B, it's Q. So we're going to go A squared equals Q squared plus D squared. Like I said, some people sit here and they're like, Mrs. Lepp, I don't know which one to put first, D or Q. Doesn't matter. Don't waste your time thinking about it. Write a letter and move on. Yeah. Then whatever letter it is that you put in. So if this was smiley face and a smiley face, you'd have little smiley face squared, capital smiley face. Yeah. Minus 2 times Q times D cos A. Okay. Now, what if I asked you to find Q or D? What if I asked you to find angle Q or D? Will we still do this step? Yes, you have to do this step first. Once you've used cosine law once, once you've used cosine law once, after that, you're going to use sine law. So we have a squared equals 468.2 squared. What? I just put that in D spot. Am I going to like die inside? No, it doesn't matter. I could have D first or Q first, but if you write the actual number correctly, it would be much more helpful. I wrote 46 and it's not, so that's good. Erase that. Okay, Q 692.6 squared plus 468.2 squared minus 2 times 692.6 times 468.2 cos of 78.6. And what do I have to remember to do? Square root this entire thing to get side A. Luckily, they're asking us for side A, so whatever we get on our calculator, we can round because we've gotten the final step. Everyone try it out. Because I'm going to ask someone for the answer. I'm not telling you who that someone is. Catherine, to the nearest tenth, what did you get? 755 meters, right? And we're done because they just wanted to know the length of the swamp. Now, what if they wanted more? What if they wanted an angle now? Then we would have a side angle pair and we could use sine law. So you only ever at most have to use cosine law once. After that, you can always use sine law. Okay? And if you don't know how to use sine law, you're going to have to learn how to use sine law. All right. You guys try this one out. Okay, we're going to go through this one. We have triangle ABC. So your triangle ABC, we have to label what we know. So side A is 11. Side B is 5. Angle C is 20. I know I have SAS. The moment I have SAS, I have to use A squared equals B squared plus C squared minus 2BC cos A. But we change for what we know. So we're looking for actually side C. I don't care if they ask me to find A or B angle. I have to find side C. Okay? So if I'm looking for C, then this becomes C squared, and this becomes cos C. Because those two always match. And then these are just the other sides. The other sides are A and B. So A squared plus B squared minus 2AB cos C. Like I just changed the letters. I don't rearrange it to solve for C, right? I change the letters. So now I have C squared equals 11 squared plus 5 squared minus 2 times 11 times 5 cos 20 degrees. And then I square root. Now I know it says unknown angles and sides to the nearest tenth. We can do that for the answer, but when we keep going, we don't really want to round. So square root of 11 squared 2 times 11 times 5 times cos 20. And you should have gotten 6.529457723. If you keep 4 decimal places, that makes me happy, but you really should keep them all. The answer for C, then, side C, is going to be 6.5. We can write that over here because we know we need to have the length of the unknown side and the measure of the unknown angles. So I've used cosine law once. I will never have to use cosine law again on this triangle. Once you've used it once, you can use sine law after that because now I have a side angle pair, 6.529, right? So now I'm going to use sine law. So I go sine of the sides I know. So sine, my side angle pair is C. So sine C over little c equals, and now I have to find either angle. It doesn't matter which one you pick. The other one you're just going to subtract from 180, right? So I'm going to pick A. I could have picked B and I would be just as correct. So sine 20 degrees over 6.529455723 equals sine A, we don't know, over 11. Now, if we're looking for an angle, remember, if we look for an angle, we know ultimately in the end we're going to have to second sine that function or second cos that function, because that's the only way you can get an angle is if you inverse, put that thing away. All right. So I always do the unknown one first. Side length, 6.529455723 sine A equals 11 sine 20. Then you divide by this big angle, or big side. And that cancels. And now I'm left with sine A. I have to sine inverse. And so I'm going to get A equals. Now, if you put this in all at once, remember the top needs to be in its own brackets because it has to know that you multiply those first and divide. Or you can just, I always do that first. Go 11 sine 20, hit enter, divide it by the decimal 6.529455723, and then second sign, second answer. So I get 35.18315746. Okay, then I take that angle and I go over here and I say angle A equals 35.2 degrees. And now I still need angle B. How do I get angle B? 180 minus that answer that we just got, minus 20 degrees, and C should be 124.8. Something is shady. Something is super shady. (11 sine 20). So this one is off, and that's why I said it's off. If you look and remember the largest angle should be across from the largest side, and the smallest angle should be across from the smallest side. And this is what I'm saying here. This is 35. This is 11. Then I'm saying that B is 100 and something, and this is 5. Something is off. Okay? You always have to solve for the smaller angle first. And the reason why is because of the ambiguous case, which we're learning tomorrow. The ambiguous case causes it that if you don't solve for this one first, triangles, if you have a certain length of an arm, can be drawn like this, or they're going to be able to be drawn like this. Okay? You can end up having a really big angle at it, or you can draw it with a smaller angle, which the ambiguous case will make sense tomorrow more so. What you need to do is you always need to solve for the side that's the smaller side using sine law first. So you'd have to actually solve for sine B first, not A. Or you'll end up getting the other case of the ambiguous case. So if you did B instead, sine B over B, so you do sine C is sine 20 over little c, which is 6.529 equals sine b we don't know, over 5, you're going to go 6.529 sine b equals 5 sine 20. Divide by that 6.529 and then second sine it. Then you'll get the right one. So second sine of 5 and you get 15 point. You'll get b equals 15.183157, etc. So you get b is 15.2, and then you can subtract from 180. So you can take that 180 minus second answer minus 20, and you get 144.8. Now this makes sense, because before it didn't make sense. You can't have a teeny tiny angle across from the longest side and then the smaller side across from the next side. You can't do that. Your biggest angle needs to be across from the biggest side, and then b here is 5 and it's 15, which is less than 20. So now it makes sense. Okay, your triangle has to make sense. Your smallest angle then would be 15 point something, 15.2, and then the smallest side's across from it. Your next angle, which is 20, then 6.5, then 144 and 11. So the biggest angle needs to be across from the biggest side and the smallest angle across from the smallest side. Yeah. If you take these two angles and subtract from 180. Yeah. So that's why you always have to look for this next smallest one first. You can find out if you've solved for the wrong one just by putting it back in your triangle and saying, holy, that doesn't make any sense at all, right? Like when I said, hey, this is 35 and this is 100, but the side length is longer. Go back, try again. Your triangle needs to make sense. Okay? Now this is that last one where you're going to be having 3 sides. So 2 ships set sail from Port P. 2 ships set sail. 1 ship, another ship. The first ship sails 7 kilometers to R. So 7 kilometers to R. And the second ship sails 8 kilometers, so a little longer, to Q. The distance between R and Q is 13. Determine the angle between the 2 ships. What you need to find first, you guys, always find the biggest angle. So find this one first. Find angle P first. So we do cos P equals. Now if you look at your formula sheet, where does the same side and same angle work? So if you look at that formula sheet, the angle you're looking for is the side that gets subtracted, right? So it says cos A equals B squared plus C squared minus A squared over 2BC. Do you see that? So the angle matches the side that's being subtracted. So what we're going to do is this is little p, this is little r, this is little q, okay? What we're going to do is we're going to subtract the side that matches. So we're going to add the 2 sides that don't. So r squared plus q squared minus p squared. And it didn't matter if you put q squared plus r squared, that doesn't matter. All that matters is that you have to subtract off the side that matches the angle. Does that make sense? And then over to the 2 sides that don't match, RQ. So P is only going to appear in that subtracting spot. So cos P equals 8 squared plus 7 squared minus 13 squared over 2 times 8 times 7. But we need to get P by itself, so we're actually going to have to cos neg 1 because we're finding an angle. Now, if you want to put this all in at once, you're going to have to put brackets around the top and brackets around the bottom. So either do the top divided by the bottom in brackets, or you can just go second cos bracket the top. 8 squared plus 7 squared minus 13 squared bracket. So you're going to bracket around the top divided by brackets around the bottom. 2 times 8 times 7. You should get 120. So if you're someone who can't put the whole thing in, that's fine. Go 8 squared plus 7 squared minus 13 squared, hit enter. Divided by in brackets 2 times 8 times 7, hit enter. And then second cosecant your answer. There's a few different ways you can do it. But you should get 120. And always find the biggest angle first. If not, you're going to run into that case where we had the error last time, right? You have to inverse cos anything to just get that cos to go away from the piece so you can find an angle. Remember, whenever it's 120, whenever you need to get the angle by itself, you have to inverse cos. Okay, now we want to find which one? The angle between the direction of the two ships. We've got it. What if they didn't ask us for that one and they asked us for the angle of between the ship and point P? So say they asked for this angle. We would still have to find the biggest angle first and then use sine law and find the next one. Okay? If you don't do that, you're going to run into that sine law error again where you could end up with a smaller angle than you want. Okay? So what's the moral to this? Find the biggest angle when you're using this side, side, side. And this one here, when you're looking for your second angle, look for the smaller one. And then solve for your biggest one last, and then you don't get errors. How do you catch if you made an error and solve for the wrong one first? Check out your triangle and see if it makes sense. Okay? This is the biggest side. 120 somewhat makes sense. If this was like a 5 degrees, you'd be like, eh. If this is 5 degrees, then I have like 175 left to split between these two, and this angle needs to be bigger than those two. It doesn't make sense. So make sure your triangle makes sense, okay? This is your homework. On the top of the next page.